So sine and cosine on the unit circle. This is what I was talking about before. This is our unit circle here, all right? And what I'm doing here is tying in some geometry concepts about right triangles. This is a right triangle on the unit circle. This unit circle is also superimposed over top of a coordinate plane. You just can't see it. Okay, here's my grid lines, all right? And it's so zoomed in that I can only see, you know, -1 to 1, right? So this coordinate here is actually 1, 1. This coordinate here we already know is 1, 0. Okay, so this is your x-axis, and this is your y-axis. And again, we're super zoomed in here, so we can only see those first sort of 4 blocks, okay, around the origin 0, 0. Okay. So this coordinate here would be an x, y value. We see here that that coordinate does not actually reach 1 for x or y, okay? So these are all fractional decimal values in here, all right? But what I'm using here is some geometry. Remember, sine is opposite over hypotenuse, so the sine of theta here is opposite over hypotenuse. Okay, well, I have r here for radius because that's the radius of the circle. Remember, the radius of the unit circle is 1. So really, sine equals opposite over 1, okay? And in this particular case, opposite is the y value of the coordinate. So y over 1 is y, okay? Cosine is adjacent over hypotenuse. So here's the x side adjacent, okay? Again, the hypotenuse is 1 because it's the unit circle. So really, cosine is x over 1, or just x. Tangent, if you remember from geometry, you actually talked about this. Okay, tangent is opposite over adjacent. In this particular case, that's y over x. You use tangent in geometry or use slope actually to define tangent for the first time in geometry. Okay, because that's the rise over the run. So we're going to use these definitions here, and that's how we come up with this coordinate, okay, cosine comma sine. So on your unit circle, at every angle, there's an x and a y value represented by the cosine of that angle for x and sine of that angle for y. All right. Let's take a look at a couple of examples. Well, first let's tie in our right triangles here so you know what those coordinates look like. This is the 30-degree triangle. Okay, it's also used for the 60. Now we did this in class, so I don't know that you necessarily need this, but what we're trying to get across to you here is that the x value is √3 over 2. That's the horizontal value. The y value is 1/2. Okay, one other item of note that you're going to want to remember is that √3 over 2's decimal is 0.86. Okay, √2 over 2 is 0.71, and 1/2 obviously is 0.5. Because your calculator is not going to give you the exact values. These are the answers that we want. Okay, these are the answers that the calculator gives you. Okay, so you got to remember that if you're checking your work, okay, this is what you're looking for. Let's take a look at a couple examples. You have to have your unit circle out for this. I don't have mine. I'm doing mine from memory. Okay, but you know, I'll try to piece it together here the best I can, right? This is the unit circle. Okay, so the sine of 45, so I'm locating 45 degrees. I'm looking at the coordinate for 45 degrees, and I'm looking at the y value because it's sine and it's √2 over 2. If you type sine of 45 in your calculator, you would have gotten 0.71. Okay, cosine of 150, so I'm locating 150 on my unit circle, which is right here. I'm looking at the coordinate for 150, okay, and I'm looking at the x value, which is -√3 over 2, because cosine is x, so -√3 over 2. Tangent of 330. Now, tangent's tricky. Let's skip that one and come back to it later. Okay, let's try these other ones first. So sine of 3 pi over 4. Now I'm switching it up on you. If you're using your calculator, now you got to change your mode to radians, okay, because it's given to you in radians. But I'm not using my calculator. I'm using my unit circle. Right here is 3 pi over 4, and I'm looking at the coordinate there, and it's sine, so I'm looking at the y value of that coordinate, which is √2 over 2. All right, I'm writing all these as fractions because my directions say exact value. Cosine of -5 pi over 3. So now we're sort of lump all of these concepts together, okay? And to find that, we have to first find out what the positive coterminal angle is there. So -5 pi over 3. Well, right here is +5 pi over 3, right here. So if I reflect that over my x-axis, all right, I would get -5 pi over 3, which is the same as pi over 3. I'm looking at the, x value of that coordinate, which is a half. Now, if you have your calculator out and you're in radians, you could type in cosine negative 5 pi over 3, enter, it's going to give you 0.5. All right, so let's take a look at these tangents that we've been avoiding. Okay, so we'll do tangent of 330 first, right here. Okay, so find 330. All right, 330 is right here. Now for tangent, I'm going to need both the x, root 3 over 2, and y value, 1/2, to do this. And tangent is defined as y divided by x. So it's going to be 1/2 divided by root 3 over 2. Now, in the world of math, fractions inside of fractions is something that's frowned upon. So instead of dividing by the fraction root 3 over 2, okay, remember our strategy is to multiply by its reciprocal, which is 2 over root 3. All right? When we do that, the 2's cancel, and I actually end up with 1 over root 3. Now, you could let your answer like that, but yet again, sorry, square roots in the denominator is another one of those parts of math that are frowned upon. Not illegal, just frowned upon. So I would have to rationalize this denominator. We talked about this in unit 0. To rationalize the denominator, you multiply by whatever root is in the denominator. So by multiplying by root 3 over root 3, in essence, I'm multiplying by 1. But that helps me because 1 times root 3 is root 3, and anything times itself is that thing squared, which is nice because the square and the square root cancel, and I'm left with just a 3. So this is the best answer for the tangent of 330. This is an answer that I would accept. Okay, and this right here, you're probably going to lose a point for not simplifying. Let's try tangent of pi over 4. That's a lot. I get it. Okay, so here's pi over 4. So we have root 2 over 2, comma root 2 over 2. So again, y over x, root 2 over 2, over root 2 over 2. We don't want to leave it like that because that's fractions inside of fractions, no good. So remember, the alternative is to multiply by the reciprocal of the denominator, which is 2 over root 2. Now in this particular case, 2 on top, 2 on bottom cancel. Root 2 on top, root 2 on the bottom cancel. What am I left with as my answer? 1. Which makes sense because anything divided by itself, okay, always gives us 1. And we know that this is an isosceles triangle because these two sides are equal.